Which diagram shows the arrangement of particles inside a balloon containing a mixture of the gases nitrogen and oxygen? Nitrogen, as we've seen and drawn many a times, is just N2, right? That means one nitrogen atom has a triple bond with another nitrogen atom. Oxygen is similar, O2. One oxygen is bonded to another oxygen atom by a double bond. This is called a diatomic molecule when you have just two atoms in that molecule. Extra knowledge, right? So if I look at a closer look at A, they seem to be, I don't know which is which, but they just seem to be atoms of each other, nitrogen. Over here, they look like molecules, kind of like N2 and O2. That's fine. Over here at C, they're also atoms of each other. Okay, so there's no big difference between B and C, but I think these two are the more likely answers. Let's take a look at D. Over here, they show one oxygen molecule atom bonded to a nitrogen atom. We still don't know which is which, but I mean, we can tell they're bonded to each other rather than to themselves separately, right? Oh, we do know nitrogen. Silly me, I had my hand over this area because I was writing. Oh, well, we do know. So over here, it looks like nitrogen atom is bonded to an oxygen atom. Take it. So this is out. So that's not N2 or O2 anymore. This is more like NO, because nitrogen is bonded with an oxygen, right? So that's not it, right? It could be B or C. We already discussed A, isn't it? What's the difference between B and C is that all the nitrogen molecules are on one side and all the oxygen molecules are on the other side. They'll mix together, they'll diffuse. There's no great density difference between the two. So they'll mix together. And yeah, so C is the more likely answer. C. If you know your dots and crosses, this is a question about that. Which dot and cross diagram showing all the outer shell electrons for each atom is not correct? Now, we did this in class and they're all correct. The only thing, like if you're focusing on the bond, which normally people would, is their bonds are all correct. The only problem is with B, and if you're taking a closer look at the question, outer shell of electrons, which in dot and crosses you have to draw, chlorine does not have all of its electrons drawn. It should have 7 of its own electrons and 1 from hydrogen for the molecule of HCl. So B is not correct. Ethane, C2H6, and ammonia, NH3, are covalent compounds. The dot and cross diagrams of these compounds are shown. Which statements are correct? A molecule of ethane contains twice as many as hydrogen atoms as a molecule of ammonia. How'd that highlighter come over here? Okay. Is that true? Well, ethane has 1, 2, 3, 4. It has 6. What's wrong with me? It has 6 hydrogens in one molecule, whereas ammonia has 3. So this looks correct. An unreacted nitrogen atom has 5 outer electrons. Yeah, nitrogen is in group 5. So, yep, 5 electrons. And over here we can see 1, 2, 3, 4, 5. That's correct as well. In a molecule of ethane, the bond between the carbon atom is formed by sharing 2 electrons, 1 from each carbon atom. That is what a covalent bond is. It's a sharing of electrons between 2 atoms, 1 from each individual atom. That's true. Over here it might look a bit confusing, but that's essentially what a covalent bond is. Because it's confusing because both carbons they're using the same electron symbol for it. Both are X's. So it might get confusing, but it's true nonetheless. If you ever make a dot and cross diagram for ethane, you know it's true. That's what you use to draw it, that information. So the answer is 1, 2, and 3 are correct. So that's A is correct. A. All right. Which dot and cross diagram is for NCl3? Now NCl3 is a molecule we haven't done. You might get intimidated, but more often than not, know this, more often than not, what's going to happen is that the new molecules that are given to you will be very similar to the ones we've already done before, right? Now NCl3 might look very alien and complicated, but it's exactly the same as ammonia, NH3, exactly identical. Now the dot and cross diagram for this is something like this. Right? Now for chlorine, obviously you won't have just one electron coming from hydrogen. This is ammonia, right? But if you replace hydrogen with chlorine, chlorine will have its other 6 electrons over here. So let's try to match this that way. Okay. If we look at D, this is the closest to me. So D, each chlorine atom over here has 5 electrons, not 7. Chlorine is in group 7. It should have 7 electrons. D is incorrect. If we take a closer look at C, I think this is it. 7 electrons for chlorine. Nitrogen has 5 electrons, and they're all tamiz se bonded, a lot like ammonia over here. Very identical to ammonia, right? So I think C is the answer, but let's rule out A and B as well. B has the same issue where nitrogen is correct. Chlorine has the wrong number of outer electrons. It still has 6. So B is out. And I think a similar issue is present with A, where nitrogen has the wrong number of electrons, whereas chlorine is. One fact to know is that I think I went through this, and I believe people generally go through this as well, is that they forget nitrogen is one of those atoms you just forget is in group 5. You keep thinking it's in group 3 because, NH3, or maybe it's just a diatomic molecule N2. So you forget a lot because how the electrons are arranged, and you forget that nitrogen comes from group 5. So just be aware of this. Nitrogen is in group 5, has 5 valence electrons. When it's in NH3, 2 electrons are not bonded, whereas the other 3 are bonded. Okay, let's move on. The answer is, which diagram shows the outer electron arrangement in calcium fluoride? Now, there are 2 kinds of bonding present in, generally, right? There are 2 types of bonding. One is covalent. The other one is ionic. Covalent only occurs between a non-metal to a non-metal. No exceptions. Whereas ionic only occurs between a metal and a non-metal. What happens between a metal and another metal? Nothing really, right? This does not exist. Whereas ionic is always a metal with a non-metal, and a covalent will be a non-metal to a non-metal. Okay. And with that in mind, I think this question becomes a lot simpler. We're talking about calcium fluoride. Will this be ionic or covalent? It's going to be ionic because calcium is in group 1. Let's write that down. This is in group 1. Fluorine is in group 7. A metal versus a non-metal. Conditions for ionic are met. So A is out, B is out. How am I confident that they're covalent? There's an overlap of orbitals where they're sharing. So these electrons are both present with calcium and with fluorine. So it's a sharing. The overlap implies sharing and a covalent bond. Both A and B are out because of this overlap. Then remains C and D. Now at this point, I apologize, this diagram is slightly cut out. It's a big picture. Okay. But at this point, you got to realize that one thing, which is even if you don't know the correct charge on calcium, fluorine and calcium have negative charges, so they'll never attract each other. they'll always repel each other. So if they're repelling, why would they make a bond? Whereas C mein, there's a positive charge on calcium, correctly so because it's a group 2, and negative 1 on fluorine, correctly so indeed, because it's from group 7 or 17. And there will be attraction between the two, which is an ionic bond. So the answer is C. Yay! A similar question that's testing what we just discussed previously. A compound formed between elements X and Y is ionic. Which statement about elements X and Y is correct? X and Y are both at the left-hand side of the periodic table. Left-hand side is where group 1 and group 2 are. So that means both X and Y are metals. Ionic bonds are between a metal with a non-metal, right? That's how it is. It's going to, A is wrong. B, X and Y are both on the right-hand sides of the periodic table. Well, that's a non-metal and a non-metal. Non-metal with a nim-nim, right? And that's talking about covalent bonds, not ionic bonds. So B is talking about covalent bonds. B is also incorrect. C, X and Y are both transition elements, where all transition elements are metals anyway. So that's incorrect anyway. X is at the opposite side of the periodic table from element Y. Yes, because metals and non-metals are on extreme ends of the periodic table. Okay, so D is the answer. Woo! Which molecule has the largest number of electrons involved in a covalent bond? Over here, your ability to be able to recognize ethene is important. Now this question is slightly unfair because it's talking about methanol, CH3OH. We talked about ethene, we talked about ethane. Anything else you don't really need to know. So if C is the answer or anything like, I won't have this question, right? Don't worry about this too much until we do hydrocarbons. But we did talk about ethane and ethene and methane. You guys should be able to draw those out or identify what sort of interaction is going on between them. So ethene, this is what it looks like. I'll just show the bonds. This is ethene with hydrogens. Okay. Then I have CO2. That's a double bonded O. Then I have, just because for the sake of it, we'll draw methanol. This is what it looks like. Methanol. And N2. This is what N2 looks like. Which molecule has the largest number of electrons involved in a covalent bond? So one covalent bond, if you want to do the math real quick, this is how you do it real quick. One covalent bond, one covalent bond, just like C, one covalent bond is 2 shared electrons. Okay. Now a bond in all of these diagrams is represented as a Dundee. So one Dundee or one stick or one line, one of these lines represent 2 electrons. So what I do is I count the number of these sticks or these lines and I just multiply it by 2. Okay, let's not write it like that. I'll multiply this by 2 and I'll get the number of electrons in total. Okay. So how many sticks do we have, or Dundees or lines do we have over here in the first one? We have 1, 2, 3, 4, 5, and 6. So we have 6 times 2, 12 electrons. Over here we have 4 times 2, 8 electrons. Over here 1, 2, 3, 4, 5. We have 5 times 2, 10 electrons. Over here we have 6 electrons because 3 each, 2 each for 3 bonds. Okay. Which has the largest number of electrons involved in covalent bonds? Note we're not talking about any valence electrons, like oxygen over here might have a few, right? We're just talking about count of electrons shared in the bond, taking part in the covalent bond. So the correct answer, the answer over here right now is A, has the most electrons. Which statement describes ionic bonding? A lattice of ions in a sea of electrons? No. No. Electrostatic attraction between oppositely charged ions? That's literally the definition of ionic bonds, isn't it? I'm pretty confident it's here. I'm voting B until I see something that's more interesting. Taking a closer look at C, the sharing of electrons between atoms to gain a noble gas configuration. It's not the sharing. They don't share. Ionic bonds do not share. They're talking about covalent bonding. So that's incorrect as well. Gone, bye-bye. The transfer of electrons from an atoms of non-metals to atoms of metals. Wait, that's exactly what ionic bonding is. When there's a twist, non-metal to a metal. The transfer of electrons from atoms of non-metal to an atom of metal. Metals give electrons and non-metals receive electrons, right, in ionic bonds, because they get a negative charge, they get a positive charge. It's the other way around, but so it's wrong. The statement is wrong. So the correct answer is B. All right. So which molecule has only 4 electrons involved in a covalent bond? Well, we'll have to figure it out. But I think all of these molecules are very familiar to us except the first one. And you might be thinking, oh, what do I do now? Maybe I can use the periodic table and figure it out. Well, that's exactly what's intended. But 99% of the time, you're getting a molecule which is very similar to some other molecule which we've already studied in detail in class. Like when we saw NCl3, we realized very quickly, or as I told you guys, it's very similar to NH3, right? So even though they're not part of the same group, very similar, right? H2S, if we look at sulfur in the periodic table, it's going to be in group 6, right below oxygen. Okay. Now, because it's in the same group, they'll bond identically. Isn't that the case? So what does the bond... So I don't want to... What I'm saying is, I don't want to do the math and try to recreate it. I can cheat. I'm encouraging you guys to cheat. What does the world come to? This is what a water molecule looks like. It has 2 bonds, one with each, right? And this is exactly what a H2S dihydrogen sulfide would look like. Very identical. Which molecule has 4 electrons involved in covalent bonds? Each of these Dundies or each of these bonds are 2 electrons each. 2 here, 2 here. A total of 4. The answer is A. But let's rule out why B isn't the case and why C and why D isn't the case. This is what carbon dioxide looks like. We know it, we love it. This has 8 electrons because it has 4 bonds. 2 double bonds. Then we have chlorine, which has 2 electrons, not 4. And then we have nitrogen, which has 6 electrons because it has 3 bonds, a triple bond. Very identical question from what we did earlier. The answer, you know it, it's 6, but I'll do it anyway. These are 6 electrons being shown. 6. Which molecule contains 3 shared pairs of electrons between 2 of its atoms? And I think the answer is just N2, right? Because we've seen this. Each Dundee is a paired electron, and these are 3 shared pairs or 6 electrons. Either way. Just a different, it's the same question. They, instead of saying 6 electrons, they said 3 pairs, right? 3 shared pairs. And we're done. Which molecules all of them contain 1 or more double covalent bonds. 1 or more double covalent bonds. Okay. So if I take a closer look at A, has chlorine, nitrogen, and methane. Methane is one atom I have told you guys, and we've done it in class. You guys should be familiar with this molecule. Okay. So none of them have double bonds. Okay. So it's not A. And chlorine shows up in B, so it's not B. I don't even want to bother with the other two, but oxygen and ethene are there. They'll be part of it, but we want all three to be double bonds. Oxygen, hydrochloric acid, ethene. Hydrochloric acid, no. C is out, D is the answer, and let's prove it. This is what oxygen looks like, this is what carbon dioxide looks like, and this is what ethene looks like. We witness sulfuric acid, H2SO4, the molecule. A molecule of sulfuric acid has a structural formula shown. How many electrons are involved in the covalent bonds of one molecule? Well, that's easy. We just count the number of total Dundies again, and that's it. And then we multiply it by 2. So these are 2 Dundies, 1 Dundee, 1 Dundee, and 1 and 1. So 4, 5, 6, 7, 8. 8 bonds mean 16 electrons. D is the answer. What am I doing? In order to form a compound with oxygen, an atom of group 2 element must transfer 2 electrons to an atom of oxygen. I think we're on the right track. Receive 2 electrons from an oxygen? No. Share 2 electrons? So group 2, right? Metals, and oxygen is a non-metal. So the type of bonding they'll have is ionic, where the metal will form a positive charge and bond with oxygen, which has a 2- charge. Or group 2 have, so it will form a 2+ charge, and they'll just share electrons. Oh, not share, donate, metal will donate electrons. So transfer 2 electrons, we're pretty confident at this point. Share 2 electrons with an atom of oxygen, not share. Bond with 2 atoms of oxygen, nope. Right? A is the answer. Some students wrote down 3 statements about the bonding in the molecule of ammonia, NH3. So, what is ammonia really? I mean, what is it? Let's get philosophical here. It's NH3, and that's how it's bonded. It has 2 bonds, 2 electrons that are not bonded, nitrogen, because it can go up to 3 bonds, and after that it's happy. Then you have 3 other dots representing the bonds from nitrogen bonded to hydrogen. So let's take a closer look at the question. A nitrogen atom has 3 outer electrons, so all outer electrons are involved in the bonding. It has 5 outer electrons. A nitrogen atom has 5 outer electrons, so 2 outer electrons are not involved in bonding, exactly what I said. A nitrogen atom shares electrons with each of 3 hydrogen atoms. That's absolutely true. 2 and 3 are correct. The answer is C. Right? An ionic compound has the formula XY, where Y is a non-metal. So that makes X a metal. That makes X a metal and Y a non-metal. An atom of X lost at least 1 electron to form a positive ion. Well, that's true. Isn't it? It lost an electron, metals lose their electrons. Both X and Y share? Nope. Covalent. Sharing is covalent. Element X is also a non-metal. Nope. It won't be ionic otherwise. X and Y will not conduct electricity when liquid. That's more of a, we haven't really talked about this, but everything else seems to register well, right? And we're confident A is the answer. D will figure out when we cross that bridge, once we get there, sort of thing. Element Z from group 2 of the periodic table reacts with chlorine, an element from group 7. Okay. So group 2, element Z is going to be group 2. So it forms an ion with a charge of 2 positive, whereas chlorine will form a charge of Cl minus. So how would they bond? 2 plus Cl minus. We do the swishy swashing, and we'll get ZCl2. Z, right? Z. What am I doing? Z. Okay. And A is the answer. And if you're confused about this, we can just name Z. It could be any group 2. They all behave the same. They all behave the same, right? So let's pick magnesium, I think. I can also think of calcium. Both form MgCl2 or CaCl2. Okay, easy. The answer is A. All right, easy question. How many of the molecules shown contain only one covalent bond? One covalent bond. So the first one is Cl2. That's a badly drawn C. Cl2, that's what it looks like. Then you have hydrogen. Then you have HCl, that is one bond, right? Nitrogen, where we know it, we love it. Nitrogen is triple bond. Oxygen has a double bond. So there 3 out of the 5 have only one covalent bond. Answer is B. X represents the element of atomic number 8 and Y represents the element atomic number 19. If we have the periodic table at hand, we know we're talking about potassium and oxygen. 2 elements react together to form a compound. Which row is correct? So we're talking about compound. It can only be ionic because it's a metal and a non-metal, right? Ionic only. So potassium is in group 1, oxygen is in group 6, 16, right? So potassium will form a charge of positive 1, oxygen will form a charge of 2 minus, and to balance it out, it's going to be K2O. That's an ionic compound, potassium oxide, dipotassium oxide maybe, right? And so X is oxygen and Y is potassium. So where do I see that? Y2X. B is the answer. One atom of element X and 2 atoms of element Y react to form an ionic compound. Element X forms a positive ion. So 1 atom of X and 2 atoms of Y react to form. Okay, one's a metal, one's a non-metal. Element X forms a positive ion. So X forms a positive ion. It could be 2, 3, 4. I don't know yet. 1 atom of element X and 2 atoms of element Y. So Y has to be the negative one. So you need one of these and 2 of these, right, to form an ionic compound. So the chemical formula they're saying is the charge on them is positive. I don't know how much. Positive 1, 2, 4, 6. I don't know. Negative over here, but it could be negative 1, 2, 4, 6, right? Who knows? But they're saying the chemical formula is this. So I'm gonna bet it's going to be X2 plus and Y with a minus charge, because that's how magnesium chloride and group 2 versus chlorine, that's how they react. And lo and behold, we have chlorine already in the mixture. Chlorine with sodium will make NaCl, not in our ratio we just kind of figured out. The other one is calcium chloride, which is going to be CaCl2. I think that's the answer. Answer is A. The diagram shows part of the periodic table. Which 2 letters represent the elements that can react together to form a covalent compound? Covalent compound will always be what? Non-metal to a non-metal, right? That's how covalent compounds form. Non-metal to a non-metal. Okay. D is the. How many shared pair of electrons are there in carbon dioxide? Well, 4 and not 8, right? Because carbon has carbon has 4 bonds, 2 double bonds. Each double bond is 1 shared pair. And well, that's it. Answer is B.